first reaction we're going to perform today is the reaction between a metal and a non-metal. I've mixed in an evaporating dish 2 grams of zinc with 1 gram of sulfur. You'll have to trust me on this, but when I mixed the zinc and the sulfur together in this evaporating dish, a chemical reaction did not take place. You can actually tell because you can see the properties of the zinc and the sulfur. I've not created a compound between zinc and sulfur, I've created a mixture. In order to cause a chemical reaction to take place, we're going to have to supply energy, and we're going to do that with a Bunsen burner flame. I've mixed thoroughly the zinc and the sulfur in the evaporating dish and placed the evaporating dish in our fume hood. In order to get a chemical reaction to take place between the 2 elemental substances, I've lit the Bunsen burner, and I'm going to use the Bunsen burner flame as a source of energy to cause the 2 elements to chemically react. You'll want to record your observation of the reaction between zinc and sulfur in your data table. To make a point about chemical reactions, we're going to now make some physical and chemical observations of properties of sulfur, zinc, and the product of their chemical reaction we just saw. A physical property we're going to look at is color. In our first test tube, I have a sample of sulfur, which has a characteristic yellow color to it. In the middle test tube, I have a sample of zinc, which has a characteristic metallic color of silver. In the third test tube, I have a sample of our product, which has a white color to it. The second property we're going to look at is a chemical property. We're going to look at the reaction between each of these different substances and deadly hydrochloric acid. I have 3 test tubes of the hydrochloric acid here, and we're going to add a sample of each of the different substances to this test tube and watch for any reaction. First, some elemental sulfur. When the sulfur is added to the hydrochloric acid, there appears to be no change whatsoever. When a material has no chemical activity with another, it's termed inert. We could say that sulfur is inert with hydrochloric acid. Now we're going to test a piece of zinc metal with the hydrochloric acid. When the zinc metal comes in contact with the hydrochloric acid, it begins to bubble immediately. Anytime you create a new material, whether it's a new gas, a new solid, a color change occurs, that's evidence of a chemical reaction. So this is evidence that a chemical reaction is occurring between the zinc and the hydrochloric acid. To identify what this gas is, we're going to do a flame test. I've lit a splint to create a burning splint. I've trapped the gas in the test tube, and now I'm going to put the gas in contact with a burning splint. That popping sound or barking sound is evidence that the gas that's being evolved in this reaction is hydrogen gas. To the third test tube, I'm going to add a sample of our product. When the product hits the test tube, it immediately begins to bubble. We would say that this particular substance is active with hydrochloric acid. If we want to test what that gas is, the test we're going to use is a wafting test. And this is where it would have really been helpful if you were here today. But for a wafting test, you actually move some of the gas towards your nose from the top of the test tube. And if you were here, you would notice the distinct smell of rotten eggs. So when this gas reacts, it produces a gas that's hydrogen sulfide, the gas that's produced from rotten eggs. In your data table, write down the observations of the 3 substances with the hydrochloric acid. Then, for the gaseous product observation, indicate what the identity is of the gases that were produced when the hydrochloric acid reacted with zinc and when the hydrochloric acid reacted with the product. Then give the chemical formula of the 2 gases in those 2 reactions that occurred with the hydrochloric acid. Now, why did we make those observations? Look at your data table. In terms of colors, zinc is silvery, sulfur is yellow, but the product was white. In terms of chemical reactivity, the zinc is active, producing hydrogen gas, the sulfur is inert, and the product was active, but it produced hydrogen sulfide gas. Do the properties of the products compare at all to the property of the individual elements that reacted to make them? And the answer is no. The product's properties are unique to the product itself. They're not the average properties of the 2 elements that combine them. They have their own unique properties. Why would that be? Zinc atoms have 2 valence electrons. Sulfur atoms have 6 valence electrons. When they combine to form an ionic compound, the zinc loses its valence electrons, so it now has a noble gas configuration, and the sulfur gains the 2 electrons, so it now has a noble gas configuration. Their outer shell arrangements are different, and it's the outer shell arrangements of atoms and ions that give them their properties. So once you change the outer shell electron arrangement of any chemical species, the properties will be different. But certainly the products do not have properties similar to the reactants, and they're certainly not the average. If you took sodium metal and you ate sodium metal, you would blow up. If you breathed chlorine gas, you would die. But if you chemically combine sodium and chlorine, they form sodium chloride, and you put that on your French fries at McDonald's and eat that every single day. The properties of the compound are very different than the properties of the elements that make up that compound. The second reaction we're going to perform is also a composition reaction between a metal and a nonmetal. We're going to react elemental magnesium with elemental oxygen. I'm holding in the crucible tongs a piece of magnesium ribbon. I'm going to put the magnesium ribbon into the Bunsen burner flame, and with the energy provided, that's going to allow the magnesium metal to react with oxygen in the air. I probably should have told you, but make sure you do not look directly at magnesium when it is burning. The product of the chemical reaction can be seen here, a white ash. Enter your observations for the chemical reaction in your data table. The third reaction is also a composition reaction, but this time between 2 nonmetals. I've filled a deflagrating spoon with sulfur, and I'm going to place the sulfur into the Bunsen burner flame to provide the energy required to cause the sulfur to react with elemental oxygen in the air. The sulfur, which has a low melting point, will first start to melt, but then evidence of the chemical reaction will be seen shortly after that. Here you can see the sulfur burning in its characteristic blue flame. In the data table, record your observations of the reaction between sulfur and oxygen. Reaction 4 is going to be the reaction between metals and water. These reactions will be replacement reactions, which are oxidation-reduction reactions. The three metals we're going to test with water are copper, zinc, and calcium. I have 3 milliliters of water placed in each of the 3 test tubes, and here's a piece of copper metal we're going to place into the first test tube. The second test tube, also filled with water, we're going to react with a piece of zinc metal. And the third test tube, also filled with water, we're going to react with calcium metal. In the 3 test tubes, it appears there is no reaction with the copper or the zinc. But the calcium metal immediately began to fizz and produce a gas when it was added to the water. Evidence of a chemical reaction between a metal and water would be the evolution of a gas. So in this case, one of the 3 metals actually did react. Record your observations in your data table. For the one elemental metal that appeared to react with water, we're now going to test it with red litmus paper. I'm going to dip my stirring rod into the solution with the calcium and water, touch it to the red litmus paper. This is actually turning the red litmus paper blue. The blue color indicates that the solution is now basic. That means that a hydroxide compound must have been produced, which is now additional evidence that a chemical change occurred when the calcium was added to the water. The only metal that reacted with water was the calcium. So after you've done your observations, turn to page 154 and work out the chemical equation for the reaction between calcium and water. This is a replacement reaction, which is a reaction between an element and a compound. The introduction explains how to predict the products of a replacement reaction. One tip is that when water is involved in a replacement reaction, it acts as the ionic compound hydrogen hydroxide. And if you write it that way, you'll actually be able to predict the product that matches the experimental results we saw, which was the turning of the red litmus paper blue, proving that we had a basic substance or a hydroxide compound formed as a product. If you observe the test tube containing the reaction between calcium and water, this will help you write the correct phases for the products in your balanced chemical equation. Reaction number 5 is also a replacement reaction. This time it's the replacement reaction between metals and hydrochloric acid. I placed 3 milliliters of hydrochloric acid in 2 test tubes, and we're going to test the reactivity of copper and zinc with the hydrochloric acid. To the first test tube, I'm going to add a piece of copper metal, and we'll observe its reaction with hydrochloric acid. In the second test tube, I'm going to place a piece of zinc so it can react with the hydrochloric acid. The copper is showing no signs of action with the hydrochloric acid, but the zinc is evolving a gas, reacting fairly violently, which is evidence of a chemical change that's taken place. In order to identify the gas being involved with the reaction between zinc and hydrochloric acid, I've trapped the gas and I've lit a burning splint, and we're going to see the interaction between them. That popping sound is indication of the gas reacting with oxygen in the air. And any gas that gives a popping or barking sound when it's exposed to an open flame is hydrogen gas. This shows that hydrogen gas is being evolved in the reaction between zinc and hydrochloric acid. In your data table, write down your observations for the reactions between copper and hydrochloric acid, zinc and hydrochloric acid, the observation of what the gaseous product did when it came in contact with the burning splint, and then give the identity of the gaseous product itself. Reaction 6 is also a replacement reaction. This is the reaction of metals with metal ions. I've placed 3 milliliters of a zinc sulfate solution in the left test tube and 3 milliliters of copper 2 sulfate in the right test tube. We're going to try to react the zinc sulfate solution with elemental copper metal. I'm going to add the piece of copper metal to my zinc sulfate now. In the second test tube, we're going to try to react elemental zinc with the copper 2 sulfate solution. Here's my piece of elemental zinc metal. I'm going to add it to the solution of the copper 2 sulfate. We're going to let these stand for about 5 minutes, and then we'll come back and we'll look and see what changes happened, if any. After 5 minutes, there appears to be no change in the zinc sulfate solution with the piece of copper metal. However, in the copper 2 sulfate solution with the piece of zinc metal, there's a significant change in the color of the piece of zinc. It's actually turned a black color, showing slight tinges of an orangish color to it. This means a chemical reaction must have occurred between zinc and copper 2 sulfate, while no reaction occurred between copper and zinc sulfate. In your data table, write down the observations for the reactions between the copper and the zinc sulfate and the zinc and the copper 2 sulfate. Reaction 7 is a combustion reaction. I'm going to light the Bunsen burner, and the reaction that's occurring now is the reaction between natural gas, which is mostly methane, CH4, and oxygen in the air. We're going to try to write the balanced equation for the reaction between methane and oxygen. We're going to make one observation, though, for one of the products of this chemical reaction. I'm going to take the Bunsen burner, I'm going to turn it upside down, and I'm going to hold it against the bench top, and I want us to record the observation of what we see when the Bunsen burner's flame meets the bench top. In your data table, write your observation for the combustion of the methane with the oxygen in the air using the sparker. Write down your observation of what you saw when the Bunsen burner flame came in contact with the bench top. And then I want you to try to identify what that product is on the bench top.